Alright, so we're going to jump back into limits, and this time I have a list. For the next two videos, I have a list of about 5 limit problems that I'm going to take you through. I'm going to show you the step-by-step solutions of how I would solve it. We're going to introduce another method to solve limits, which I don't believe I've introduced in the last videos, but it's going to end up being one of the most useful limit rules that you can use to solve limits. At least it's the one I've used the most whenever I do math problems. But these next two videos would be probably the most important videos for limits that I would recommend watching, because I learn best by watching somebody do the problems or just trying to do it myself. I learn by watching or learning. So if you're the same way, I think this will help you a lot. So let's start off with the first problem. So we're going to do the limit as x approaches 0 of x squared minus 4x plus 7. So the first thing to start with the limit is to just try to plug the number in. There's some problems that will look really complicated and look like it would be hell to solve, but they throw in a trick. They throw in some little gotcha that you can just plug it in and get the answer. So in this case, we don't run into any issues when we plug in 0 into this equation. So when we plug it in, we get 0 squared minus 4 times 0 plus 7. This becomes 0, this becomes 0, and we're left with 7. So it's as simple as that. Don't forget to just try plugging the number in at first before you go through all this effort to use limit rules. Alright, so that one was very simple. I do have a couple more complicated ones. If you do try it from home, you might not get all of them, and that's okay. This is just to introduce a couple different ways to solve limits. So don't get disheartened if you have issues starting out. But a lot of these methods of solving, you can create, or textbooks can create a lot of different problems from these, so a lot of problems can be similar to these. So we'll do the limits as q. We've used x a lot, but it's not always going to be x, it could be another variable. So we'll use q this time, approaches 7, of x cubed plus 5 divided by x minus 7. So in this case, if we try to plug in 7 for q into the equation, on the denominator we would get 7 minus 7, which is 0. And we'd have some number divided by 0, which is not allowed. So in this case, we cannot just plug in 7. So what I'm going to do to solve this is I'm actually going to use some of the limit rules we discussed before and try to split it up. So here I'm going to rearrange this into two components. We're going to do the limit as q approaches 7 of 1 over x minus 7 times that same limit. Let me get a different color here. Of x cubed plus 5. So we used our limit product rule, and we split this up into two pieces. On the right hand side, this is a very easy limit to solve. You just plug in the 7, and you get 7 cubed plus 5, which I'm not going to worry about even calculating that at this point. And on the left hand side, when you plug in 7, you still get something over 0. However, with this section here, we did learn this rule last time as well. Limit as x approaches 0 of 1 over x. We said before that that is the same as, or that when x approaches 0, really from the right hand side, we're going to assume the right hand side most of the time. When x approaches 0 of 1 over x, this is going to equal infinity. So if we apply that to this side of the equation. It's slightly different because it does have x minus 7 on the bottom. But as the bottom approaches 0, it doesn't really matter what you have on the bottom as long as it's approaching 0. Or as long as the bottom is approaching 0, not necessarily the variable you're interested in, but as long as the bottom is approaching 0, this is equivalent as x minus 7. You could do an inequality and actually do it mathematically, but at that point we're wasting a little bit of time. But you could say, what is it? No. We could use that inequality and say if this is, wait, no, it is this way. If this is infinity and this is larger than infinity, then this is also infinity. But really, just for this case, just know that if this is approaching 0 on the bottom, it's infinity. So really we get infinity times this giant thing. And infinity times a number is infinity, so infinity is the final answer. And if the problem did specify from the left or from the right, this might change to minus infinity, and this would change to minus infinity. If it doesn't specify anything, you can assume it's from the right, but make sure you mention that you're assuming it's from the right, or you can say it does not exist, because it would look something, the graph would look something like that. But yeah, if I was doing this, I would assume it's from the right and specify that it's from the right. All right, I hope that wasn't too confusing. That's just one method that you can use to solve. Just splitting the components into two different limits that are easier to solve in different chunks. All right, so we'll do another one here. So the limit as x approaches 2 of x squared plus 5x plus 4 divided by x minus 2. And this actually ends up being a very similar problem. There are ways you can factor this on top. I really don't feel like doing that right now, so I would solve it the same way we did last time, splitting up into components, but there are some ways that you can factor this out on top to get something, we'll call it f, times x minus 2, where this would be the same as what's on top, and then cancel x minus 2's. I'm not sure how the book actually wants you to do it, but in this case I'll do the same thing I did last time. There's not always one way to solve a limit. Sometimes you can do multiple ways. So I'll split it up. Limit as x approaches 2 of the top, x squared plus 5x plus 4 multiplied by limit as x approaches 2 of 1 over x minus 2. Same thing as before. If you plug in 2, you get some number. You plug in 2, you get 1 over 0, which is infinity or undefined. Again, same thing. If you assume it's from the right, it would be infinity. But I guess the real answer here would be undefined. And yeah, I'm not going to go through the same thing I just did before, but this would be some number. This would be infinity or undefined. All right, now the next problem is a bit trickier. You might not understand what to do right off the bat, but this is going to take a little bit of ingenuity to rearrange the equation to solve it. So we're going to solve the limit as x approaches 3 of 1 over x minus 1 over 3 all divided by x minus 3. All right, so let's think about this for a little bit. If we plugged 3 in, we would get 1/3 minus 1/3, so we would get 0 on the top. And then plugging it in on the bottom, we would get 3 minus 3 and 0 on the bottom. So there is another rule you could use that involves derivatives. I know we're not there yet, but you could use a rule. I'm going to use something different. I'm going to factor the denominator into something multiplied by the top. So we need to get this into something multiplied by the top. So I'm going to write this on the bottom here. I'm going to say x minus 3 equals something times what we have on the top. So the one good thing that I see here, this won't work for every type of problem, but we have an x and we have a 3 in the denominator on top. So what happens if I multiply this by both of these multiplied together? So in other words, saying I'm going to multiply this, or I'm going to say f is actually 3x. And in doing so, we can split these into two components and see if we get the same thing here. So multiply 3x by 1 over x, and we get just 3 because the x's cancel out. If we multiply 3x by negative 1/3, we get x because the 3's cancel out. And that's the same thing that we started with. So this might look like I pulled this randomly out of thin air, but I noticed that we have the same x in the 3 and x in the 3 in the denominator and in the numerator. So I just tried multiplying that and I saw what happened, and that ends up actually working out. The alternative would be to find this value of f that we called it before, would be to move this to the other side and solve that equation. I didn't really feel like doing that right now, but if you're really pressed, or if you have plenty of time to use, you could do that. But I just noticed that it'll work out if we multiply by 3x. So I'm going to rewrite our original problem, limit as x approaches 3 of 1 over x minus 1/3. And I'm going to change the denominator into 3x times 1 over x minus 1/3. Let's see. Oh, sorry, I switched these. So there should be a negative. This should actually be a negative 3x. Because then when you distribute the negative, you get a positive x and a negative 3. So there we go. So in the denominator, we have negative 3x times 1 over x minus 1/3. Now we have this ugly mess on the top and the bottom. So these can cancel. And we're left with the same limit of 1 over negative 3x. So limit as x approaches 3 of 1 over negative 3x. And now we can just plug in the 3. It doesn't result in a 0 in the denominator, so now we can just plug in 3 and we get 1 over negative 9. So that's the limit. Alright, and the last one I'm going to do in this video is a problem with a bunch of polynomials. So we'll do the limit as z approaches 1 of x cubed plus 2x squared minus 3x divided by 5 times x minus 1. This is a beast of a problem, or it looks that way at first, but we're going to do some factoring and it'll become a lot simpler. So we can rewrite this. Oh shoot, sorry. I said it. Okay. I'll just rename this as x. I used z's before. But again, it could be any, we could call the variable anything. So the limit as x approaches 1 of x cubed, of this thing. What we're going to do first is I notice that each of these terms on top has an x in it. So I'm going to factor 1x out. And I'm going to rename this as x times x squared plus 2x minus 3 divided by 5 times x minus 1. All right. And so I want to get something to cancel this. And now it looks like it would be easier to get an x minus 1 out of this, because this is just a polynomial with a squared term rather than a cubed term. So I will rename the top again, or factor out the top, to x times, all right, and we know we want an x minus 1, so I'm going to put that a while. Since there's a squared term, I know this other term is going to start with an x. And now I have to think of what I'm going to put here to result in this polynomial on top. So we have a minus 3, so we know that this is minus 1 times 3. So let's try that, see if this factors nicely. So when we multiply this out, we get x squared minus 3, and then add minus x plus 3x. And this results in 2x. So this is a proper factoring of this polynomial on top. We'll keep our bottom term. And now we can do some canceling. So we can cancel out the x minus 1. We're left with the limit as x approaches 1 of x times x plus 3 divided by 5. And when we plug in 1, we get 1 times 4 over 5, or 4/5. And there we go. That is going to be the last limit I do for this video. And next video we'll do another 5 limits. They'll be a little bit harder, but a lot of limits are set up in a similar manner, where you have to cancel things or you have to use some limit rules.